Hi there, this is Abhishek, and in this video I will talk about the different statistical tests which are present in the Tools Statistics Chart Wizard option. So when we click on this, we have three different options: the chi-square test, second is one sample t-test or paired sample t-test, third is the independent sample t-test. So with the help of three different videos, or maybe four different videos, because you have one sample t-test / paired sample t-test, which are two different tests, I will try to help you understand, and as well as how you can configure this wizard to get the correct output. So let's first discuss about the chi-square test, a little bit in theory. So chi-square test, as per its definition, it is a test for the difference between two proportions, and it helps identifying whether the given two different groups are significantly different than each other or not. So for example, you have the restaurant 1 and restaurant 2 as two different groups, and you want to understand, based on the customers' responses, whether they would like to return into a particular restaurant or not. Now these two restaurants, as this example says, that it is a cheesecake factory restaurant which is present at multiple locations in a city. So that means their pretty much look and feel is same, their offering is same, and because all of this similarity into the features, they have collected the feedback, and then they want to understand that from the users to understand whether they would like to visit the hotel again or not. So now, based on the feedback of two different locations, you want to know whether both of your restaurants are doing equally good or they are significantly different from each other. Now this is dependent on your responses, because restaurant 1 responses will be different from restaurant 2, and that is what you want to test, and it will help us identify whether they are equally good or they are or both the restaurants are significantly different from each other. So let's go into the tools and statistics chart wizard, and chi-square test is what we need to select. And here also some definition is given, but I felt that it is a bit technical or a bit more towards the statistical side and without the example. So that's why I thought of giving you an example over here. And let's click on next, and in the column our data, we have choice, CHOC, so that's what we will going to write. And within the rows, that means over here the column name is restaurant, so we will write RESTAURANT, and within the values we have observed as the name of the field where the values are present. So if I see observed, I will just remove the equal to sign. So most of the time it happens that I want to use the inherent feature of QlikView to give me the option, like I don't want to write entire restaurant, then I will just put equal to restaurant. Once I identified, I hit tab, and after that I'll just remove it so that it is matching up with this expectation of this result. So p-value I want to show, degree of freedom I want to show, and chi-square value. So that's all. So once I do that, I get the p-value test underscore df chi-square. So chi-square give us the value of 34, and based on that your p-value is getting derived. And what it basically tells, so before I interpret this p-value and tell you the outcome, so before that we need to frame an hypothesis. So there is a concept called hypothesis testing, and there we need to frame a question like whether two groups or two different restaurants are similar, or alternative hypothesis that they are not similar or they significantly differ from each other. Now the rule of the thumb is that we generally do this kind of a testing at 95% confidence level. That means we want to say that we are 95% confident that the result that we are getting is correct or accurate, either side it may be, and there is just 5% chance of an error. Okay, so p-value, if any of the p-value is below to 0.05, right? So 0.05 is nothing but your 5%. So if any value is less than 5%, or 0.05, then we reject the null hypothesis. So again, if p-value is less than 0.05, so here in this case 0.000, it has not shown the exact value because it is like almost very negligible, and I'll show you that number also in a couple of minutes. So what it is saying, that there is very less chance that you will find these two groups similar. That means, alternatively we can say that our alternative hypothesis is true, where we are saying that these two restaurants are significantly different. If the p-value would be somewhere around 0.06 or 0.1, which is greater than 0.05, then we would have said that our null hypothesis is true, because in null hypothesis we are saying that these two groups are same. So now let me show you the exact p-value. If I go into the properties and into the number and p, and let's say I want a number, and if I click apply, now you can see there is a value, but it is written in scientific notation because it's very low, and there is it's very hard for expression default to give you that outcome. So that's why I've just changed the formatting to number. So that's something about the chi-square test, where you can test the two similar products, maybe from different companies. For example, I'll give you another example, like cola example. So you have cold drinks from Coca-Cola and Pepsi, and based on the user responses you can get which one they prefer, and then you can design this 2x2 metric and tell the user an outcome, or your company an outcome, that which one they prefer. And that's kind of a strategy which researcher uses when they need to compare two groups. Most of the time you have seen the headlines that one group's preference is significantly different from another group. So that's something chi-square test basically does, and this is the kind of format that you would require to do the chi-square testing. That means a 2x2 format, right? If you have more than two categories, then we need to go for some other kind of testing. But if it is a 2x2 metric or 2x2 dimensional metric, then we can use the chi-square testing to know whether there is two different groups are significantly different from each other, or they are equal in nature. So that's pretty much all I wanted to discuss in this video, and I'll meet you in the new video with a new topic.